All right, 2.3, polynomial functions of higher degree with modeling. So the first one say describe how to transform the graph of an appropriate monomial function x to the n, so whatever power it's raised to, into the graph of the given polynomial. So it's going to follow the same rules that we've had for all the other ones in terms of like in the parentheses it does this, outside it does, all that. So nothing really different about those. So just doing like two of those. G of x equals 2/3 and then parentheses x minus 3 cubed plus 1. So what's happening here?
So if we go on right 3 up 1.
Right, 3 up 1. And it's compressed. Number 6, g of x equals 3 times x minus 1 to the 4th minus 2. What is this one doing?
Right 1.
Down 2 and a stretch.
Yep. All right, so now we're going to take and we're going to jump to number 26. Okay, the stuff in the just not super important stuff. So these ones say to describe the end behavior of the polynomial function using the limit as x approaches infinity of f of x and the limit as x approaches negative infinity of f of x. So that's saying as x gets really, really big or really, really small, where's the function going in terms of y?
Gotcha. That's not what I got out of those directions.
And we only care about the highest powered x term.
Right.
That's all we care about. Okay, so if you take that term and you plug in like 500, what's happening to it? It's going to infinity, negative infinity, 0, I guess theoretically.
Okay.
These ones are all going to either infinity or negative infinity. We will later have other ones that do other things, but
I think we did a little bit of that last year.
yeah, I tried to touch on it briefly last year just so that you aren't hearing it completely for the first time. And then this year we do a tiny bit more with it than we did last year. And then if you take calculus, you do a lot of it. It's like a whole chapter. So
Nice. Good to know.
f of x equals negative x cubed plus 7x squared minus 4x plus 3. So all I care about is this negative x cubed. And if they're not in the right order, make sure you pay attention to that as well to get the highest powered one, even if it's not the first term listed. So we're looking at the limit as x approaches infinity of f of x. We want to know where it's going. And then we're also looking at the limit as x approaches negative infinity of f of x. So as x gets really big in the positive direction, so pretend we put in 500 here. What is happening? Is this going to negative or positive infinity?
Negative.
Negative infinity. And then as x goes to negative infinity, so say like negative 500, what's happening?
Positive.
It's going to positive infinity.
Do you have a calculus class this year?
No.
So you don't have
And all that or physics.
calculus or
But in theory, we'll have both next year if somebody decides to take it.
yeah.
What if there's only one person? Do you still have it?
I've taught calculus to just one person 2 of the 3 years I've taught it. Last year it was only 2 people. So yes, I will still just teach it for 1.
You're gonna have people
This year I thought I was only going to teach it to 1. Initially it was 2, and then it was 1, and it was a different one. And then they both said no. So now it's none. And then right before school started, Ethan said he was going to take it. But we had already gotten it out of my schedule, so it wasn't going to work because he was taking forensics. Because that was where calculus was supposed to be. So we're like, well, it's just going to have to be next year. So
Yeah.
he's taking it next year with whoever else chooses to take it, or him by himself. I don't know.
I'll definitely do
All right, f of x equals x cubed minus x to the fourth plus 3x squared minus 2x plus 7.
Negative x to the fourth.
Yep, so I care about this negative x to the fourth. Something to just keep in mind is that the negative is not being raised to the fourth.
Right. Okay. Yeah.
Okay, it's like outside of it. Okay, yeah, it's like negative 1 times that. So, the limit as x goes to infinity of f of x, and the limit as x goes to negative infinity of f of x equals. So as x gets really, really big in the positive direction, so something like 500. So if I have negative 500 to the fourth, where is it going?
Negative.
Negative infinity. And if I plug in a negative, so negative 500, or negative times negative 500 to the fourth, what's happening?
It's still negative.
Still negative. So they can both be negative, both be positive, just depends on what you have to start with. Any questions about the limit ones? That's
So you said the negative is not big, right?
right. So if it was written like this, it would be.
Okay.
But because it is just this, the raised to the fourth or whatever power it would be is only going to be x.
Okay, so then that just adds on.
All right, the next ones. Find the zeros of the function algebraically. So this just literally means factor and solve.
Oh.
All right, 34. F of x equals 3x squared plus 4x minus 4. So we're going to factor it, use the zero product property, and solve. That's all that's happening. So how do I factor this?
The arch.
Arch
The
method?
arch. Why would I say arch?
Yep. So I need factors of negative 12 that add up to give me 4.
6 and 2.
6 and 2, which one's positive, which one's negative?
Negative
2 is
two.
negative.
2 is negative.
Yep. So 6 and negative 2. So 3x squared plus 6x minus 2x minus 4. Factor by grouping. I can take out a 3x. That leaves me with x plus 2. I can take out a negative 2. Leaves me with x plus 2. So I've got 3x minus 2 times x plus 2 equals 0.
So then, do we set them both equal to 0?
Yep, so 3x minus 2 equals 0, x plus 2 equals 0. So then 3x equals 2, x equals 2/3. The other one is x equals negative 2. So those are the zeros of the function.
This section seems like a bunch of different sections.
Put
all
together.
in one.
It really is. That's the thing, like, it's the stuff that irritates me, because it's like, this is like 82 different things being thrown into like one section, and there's only like 3 problems in each like block of like things, so it's like there's only so many for me to pick from, so I'm like, hopefully there's enough examples.
But then it also feels like this is stuff we've already done before, too.
You have, they're calling it something different technically, like I don't think I've ever, well, I may have, but I highly doubt that I've specifically said find the zeros of the function algebraically.
No, you said
No.
factor.
Yeah, I would say like factor and solve. That's probably what I've said. Or
Yeah, factor and
or
yeah.
at some point in algebra 2, we would have learned about the zero product property, so I may have said, using the zero product property solve,
I believe
which
you
is
did
all
that.
this is.
Yeah,
So.
I believe
So
you
they're
did say
just
that.
giving us different instructions that mean the same thing.
Yeah. I'm going to let y'all try this one
You're like,
on
"Cool,
your
we're gonna
own.
throw-
Same instructions as the one above.
They're like, ooh, we're gonna throw
Just
a
make them
little
think
here.
it's different by giving them different instructions.
So this section is really quite easy overall. Get an answer? What do we get?
Well, there's 3 solutions. So, I think.
Yeah.
X equals 0, x equals 5, and x equals negative 5.
Yep. Any questions about that one?
Nope, I just that out.
You need to take out an x first and then don't get rid of it. That's the common mistake. And then difference of squares. Everybody good? Sorry, I'm trying to check something on the video that y'all have for tomorrow. So, all right, the next one, state the degree and list the zeros of the polynomial function. State the multiplicity of each zero and whether the graph crosses the x-axis at the corresponding x-intercept. Then sketch the graph of the polynomial function by hand. We're not doing all of that. We're finding the degree, the zeros, and the multiplicity. So basically how many times each zero occurs is what multiplicity is. So number 40, we've got f of x equals negative x cubed times x minus 2. So when we're trying to figure out degree, okay, we are somebody out there?
Yeah.
Oh.
Ariel.
We are
Yeah,
multiplying. I can hear them now. We're multiplying the x's together and seeing how many x's we're going to have. Okay, so if I were to multiply this, you don't actually need to multiply it, but if you were to multiply it, how many x's would you have? Or like what power would x have on it? X to the 4. So our degree is 4. Zeros, so it's already factored out for you. So if you set each piece equal to 0, what are your zeros?
0 and 2.
Yeah, so x equals 0 and x equals 2. Then multiplicity wants to know how many times each of these occurred. So how many times do we get a 0 of x equals 0?
3 times.
3 times. And how many times do we get a 0 of x equals 2?
Once.
1 time. So these match up here with how many times you get each of them. For one like 42, it's maybe not quite as obvious. F of x equals 7 times x minus 3 squared times x plus 5 to the 4th. So now, because I've got two parentheses being multiplied by each other, I need to think, when I do this, if I multiplied this out 4 times, what is the highest x power I'm going to have? X to the 4th. When I multiply this one out, what's the highest x power I'm going to have? X squared. They're getting multiplied by each other. 6. Add exponents if we're multiplying. So our degree is going to be, wrong color. Degree is 6.
Okay.
So then zeros, what are they?
X equals negative 5.
X equals.
And x equals. Is it just 3? I wasn't
Yeah,
sure
and
if
when
it
there's just a number out front, so the difference with 42 and 40 was up here there was a variable out front. When it's just a 7 out front, you can just imagine it being tacked on to the x minus 3.
Okay.
Like if it's just a number, or you can just get rid of it, because if you take that and set it equal to 0, when you divide by 7, it's gone. So you can imagine that it's just gone. So then multiplicity, and I'm okay if you want to abbreviate multiplicity, because one, it's a really long word to write, and also kind of a weird word to say. So how many times does x equal 3?
Twice.
And how many times does x equal -5?
Oh.
4.
Easy. Better than I thought it would be.
Okay, and then the very last thing that we have in this section, or that we're going to do, is there's a few other places where it says, like, find the zeros algebraically and all that other stuff. So, anyways, I'm not going to give you any of the hard ones that you wouldn't be able to do, because some of them you would not know everything that you would need to know to be able to solve them. So, you would do it graphically if we were going to do it, and it says, well, it says algebraically or graphically, and all I care about is if you can do it by hand. I know you can find it on a graph. So, the last thing says, find a cubic function with the given zeros, support by graphing your answer. Okay, we don't need to do that part. So 54. So we are given the zeros, -2, 3, and -5. And we want to write the function. So we're doing the reverse. So up here, we found the zeros, we were given the function. Now you're given the zeros, find the function. So think about this as x equals -2, x equals 3, and x equals -5. Because we need to get the signs right. So we're moving the numbers over to meet the x's. So we have x plus 2 equals 0, x minus 3 equals 0, and x plus 5 equals 0. So then these become our factors that are all being multiplied times each other. We're looking for a cubic function, so each one's going to get written one time. So f of x equals x plus 2 times x minus 3 times x plus 5. Now, I will tell you, sometimes you will see in the book, I think, actually we'll put the letter K out front sometimes on these problems, saying that there could be a constant term out here that we are unaware of. I do not care if you put the constant term out there. Sometimes they do, sometimes they don't. So there could be a constant that we are unaware of, like how we had 7 up here, but we're just going to assume that there's nothing there. And if there is, if you're just so ambitious, you can call it K or some other variable. So
K for constant?
yeah, well, you can pick your favorite. I mean, not X, obviously. Probably
Yeah.
not Y, but, you know, like A, B,
Oh,
C,
use O.
G, K, I don't know.
Use O and I. Yeah, those are my favorite variables.
Yeah, L. So then we just need to multiply this out. So we would get, and I'm not going to keep copying down the K. I'm just showing you that it could theoretically be there. So we've got x squared plus 2x, or well, I'm going to just write this all as one thing. So minus x minus 6 times x plus 5. So I've got x cubed plus 5x squared minus x squared minus 5x minus 6x minus 30. So then simplify x cubed plus 4x squared minus 11x minus 30. And that would be your function with the given zeros. Any questions about any of these ones? Okay. So, here, I'll give you the problems and then I'll tell you what I think we're going to do. 3, 5, 25, 27, 33, 35, 39, 41, 49, and 53.